Okay, perfect. I can see over to the other classroom as well. So far we've covered stuff about simple interest. So when we talk about simple interest, if we have a look at a graph here, here's an axis of how much the amount is. So how much money you've put in and how much money is, let's say, in your bank account, right? We have two ideas, simple interest and compound interest. With simple interest, this is just a review. The amount you put in at the beginning will increase or decrease, it depends. But for the sake of this, we're going to just look at interest. So it's how much we're going up by. We're increasing by the same amount every single time. If you have a look at this, the distance between these points, they're the same, right? So if we were to draw a graph up, it looks like a straight line. The equation that we use is I equals PRT over 100. So this is to find the interest. And if you actually want to find the total amount at any given time, you would take the initial amount that you have, the starting number, and you would add your interest to it. So you just add your interest to it. Okay. The difference between simple interest and what we're going to cover today in 2G, this was 2F. In 2G, we're going to cover compound interest. So with compound interest, the difference here is that you notice that the distance between each point gets bigger and bigger. So it's not increasing by the same amount. It's increasing by a different amount. Now there's an equation here that we have to use for compound interest. So the reason why it snowballs like this is because the amount of interest that we accumulate is based off your current value. Okay, so if you want to calculate how much interest you have in the next time, in this period here, you would have to look at this number to calculate this number over here. Right? If you want the next one, then you need the previous value to calculate the next one forward. Okay, whereas for simple interests, you just basically have to calculate it from this amount. Once you've got this amount, you add that same amount every single time. So it's always based off that first amount. So with compound interest, you need the previous one to find the next one. And this is what happens in this equation here. Now the part with a C in it is a bit of an extra part. That's what happens when we get to year 11 general maths or year 12 general maths. Okay, so this is talking about compound periods, which is basically how many times it compounds or how many times it snowballs a year. So you can see this is almost like a snowballing effect. It gets bigger and bigger and bigger every time. In this case here, if we were to find the interest amount, notice this gives you the total amount, right? But if we want to find the interest, then we have to work this equation a little bit and fix it up. We have to fix this up to find the interest. So the interest equals to, if I move this to the other side, it's going to equal to A minus P. Okay, so these are the two equations that we'll be working with today. I'll take this section here. Actually, I'll take this here. I'll take both of these actually. And I'll put it in our notes for 2G. So in the handout that you received, there are the learning intentions at the top there. We're also going to cover a couple of these words again. So we've seen principal, we've seen rate of interest, but this idea of compound interest is what's going to be discovered today. The key ideas in the textbook are also captured here as well. We do have our equations here. So if you have a highlighter, please highlight this section now. So you can highlight these sections here. But what I'm going to do as well is I'm going to put this compound interest section here. You can see the same equation that I've written here. If you block out the C's, if you get rid of the C's there, it's going to become the same equation. T, N, same. Now I'll say this again. If you don't get a chance to write all of this down, the video will be available after this lesson. And you'll be able to download and rewatch it again. Okay, I'm just checking if it's working over there. Now, I'll write the equation once again, nice and big, because we're going to go through and annotate this now. Annotate meaning we're going to write some notes on it to figure out what each of those letters mean again. This is a 1 plus R over 100 to the power of N. Now, notice how we don't have the C's here. We don't have the C's here, that's fine. Okay? Because what we're going to do is, so at the moment, we don't need that yet. So we're just going to leave it. The first thing is our A. Draw an arrow to the A, and I want you to label this as the total amount. So if we were to talk about your bank account, this is the number that will show on your balance. All right, this is your balance, your total amount. The P here stands for what word? Principal, the principal amount. So I want you to label this again. As the principal amount. You can also say your starting value as well. So how much do you start with? And we've got two more letters here. We've got the R. The R stands for the rate of interest. So we'll just call this one rate. I'll label this in this red color. Rate. And the units for this is in percent per annum. So that's what's covered there. For the amount and for the principal, the units for this will be in dollars. Dollar sign. So just remember that if they ask you to find any of these, if you write your answer, you must put the dollar sign as well. Last but not least, we've got this N here. Now this N here means the number of payments. So number of payments in total, okay? I'll just say in the time period. I'm just going to write an example there. If we're talking about 3 years, then this means that N will equal to 3. So I'll just zoom in here a bit so you can see a bit more easily. Okay, so if we talk about 3 years, N equals to 3. This letter here. My example is 3 years. This means that N will equal to 3. But if I say, if N equals to, well, let's say, let's say we have 2 years, but we compound monthly. how many payments would you have across the 2 years if you get paid out every month? Or if it snowballs every month? Yep, so if it's monthly, then that means there's 12 months in a year. So over 2 years, it will be 12 times 2. And that will be a total of 24. So here, your end value will be 24. Does that make sense? Okay, this one here is like 100% of your value, and then you're adding on that extra percentage. Good question. So to explain what this one means, this one is basically taking your current value and then you're adding onto it. So this is already 100% of the value, and then you're adding on that extra percentage. Okay. So now that we can identify each of these parts in the equation, I'll give you a moment to finish writing that down. We'll go on to the next page and we'll start the example. So on to page number 2. So everybody, let's turn to page number 2. Again, if you didn't get a chance to write down these notes, it will be on Compass under your lesson plan. I'm going to put screenshots on your lesson plan, but there will also be the video as well. Okay. So the first question here in part 1A. The first question part here in 1A, it's asking, okay, we have $500 invested. Now, the reason why I printed this out for everyone is so that you can annotate. I noticed that on the hurdle task, not many people annotated the questions. In fact, almost no one did. What does annotate mean? Steps. Annotate, note, take. Karoon. Labeling, yep, that's part of it. You can label, underline, highlight, and write notes. So on your page right now, whatever you see on the screen, I want you to actually write down on your page as well. So see how we have $500 invested. I want you to underline that. And what does this $500 mean? It's the principal amount. So this $500 here, I want you to put a capital P on it, because that's what the principal, that's a shortcut for the principal. Okay, instead of writing out the whole word. The next information we look at is at 10% PA. This 10% PA stands for the rate. The rates, that's correct. So we're going to underline this as well in a different color if you have different colors. And we're going to label on top of that the letter R, lowercase, not capital, yeah? There's one more idea that separates this exercise from exercise 2G from exercise 2F. That's the difference between simple interest and compound interest. So a big part of this question is the fact that it's compounded annually. So every year it's only done once. It only adds on the extra part once. So then the question asked now in part 1A, it says how much interest is earned in the first year. Now, this idea of interest is the extra stuff that you get. Okay, so we're getting some extra money on top of this $500. The extra amount that we get is 10% on top. So what's the percentage that we want to find of 500? Right now, 500 is considered what? What's the percentage on 500? Let's see. That's 100% of your amount, yeah? That's 100% of your amount. We want to add on an extra 10% of that. So let's actually find out how much the 10% of 500 is. How do we find 10% of 500? So I'm just going to write down in this section here, part A. I'm going to write the interest. How do we write interest without writing the whole word? I, lowercase or capital? Capital I equals to, we're going to find 10% of $500. Now, this is how much interest is earned in the first year. Okay, so that's all we're going to do. We're only going to find the first year, the amount on the first year. So pull out your calculators if you need. Find 10% of 500. This is the same as saying 10 over 100 times 500, which is, okay, 50. I want you to get used to writing this as well. Is this what you see in your bank account? Just around 50? What do you usually see? What are some extra parts on it? Dollars, excellent. And also 0.00. Write it so you see how many cents there are as well. So this is really good practice for when you get to the hurdle task or the CAT. Now, part B here says, what is the balance of the account once the first year's interest is added? So what's it asking for here if it's asking for the balance of the account? Ayan, you said $550. So what is that idea though? Correct. So for those who didn't hear it, you have to get the amount that you invested. So that's your principal amount. And then you have to add on the interest. This forms part of the equation. This idea of balancing your account is the same as your capital A, your total amount. So I want you to underline that word, that section, and I want you to write the equation underneath it. So you can see it says once the first year's interest is added. So notice here, you add the interest on top. So let's go down. We'll write our solution down underneath here. For part B, we've got our amounts. That equals to the principal plus the interest. So I've been teaching to my class. There are clear steps. You must write the formula first. Then you substitute in the next line. What was our principal?
500.
Back up here, notice how we can see it really easily. P equals 500. So we're going to replace that P with 500. And we're going to add our interest. Where's our capital I? If you search for it on the page, here it is. Yes, so you can add 50 on top of that. So our total amount now is $550 and 0.00. Excellent. So just to show you the steps here, you've got your formula. You have your substitution. And then you write your answer. This is step by step. Okay. Whenever you have a formula, write it down. Even if you're practicing it, even if you remember it off by heart, I want you to write it down every single time you do a question. Okay. That way I can see you're working out. I can see your steps. I can give you full marks for that as well. Now it says here, how much interest is earned in the second year. since we're compounding, since we're using compound interest, is our interest going to be the same in the first year and the second year? No. I'll go back to this diagram here. If it was simple interest, it would be the same. But notice here, this was our first year interest. That's how much we gained in our first year. For the second year, notice there should be more. Now, I mentioned this at the beginning of the lesson. If we want to calculate the next value, do we need the first value or do we need the previous one? We need this one here. Okay. So we had our answer for that from part B. This is how much is in your bank account right now. Okay. So we're going to use this number here and we're going to find out how much interest you're going to earn on the second year. Correct. Now, is the rate still the same? Okay, so our rate is still, what was it? 10% per annum. But let me ask you, what's our principal amount now? What's our new starting value? $550. Okay. $550. I'll just put 0.00 there.
Sir,
Hi, sir. I'll just pause this for a second.
sorry, can you speak to one of your students quickly, please?
Yes, no problem.
Beautiful.
I shall continue.
Good, how are you?
Give me a moment. I'll just show the screen again. Okay. If we want to find our interests, we need to find 10% of what amount now? Okay. So we're going to find 10% of $550. This is the same as saying 10 over 100 times 550. What will this amount? Okay, 55 what? Dollars and 0.00. Excellent. So notice here, this is how much interest you gain in the first year. You only gain $50. How much interest are you gaining in the second year? You're gaining now 55. So notice it snowballs. You actually get more. Every time when you compound, you get more on top, more on top. So I think there's part D here now. It says, what is the balance of your account at the end of the second year? So how much do you have in your bank account right now? You're at the end of your first year. Okay, how'd you get that? All right, so what equation are we going to use? What formula? Okay, so A equals to principal plus interest. Again, you write your formula first. What's our next step? Second step is substitution. So our principal in this case now is 550. And how much are we adding on? 55. Last section is your answer. You put this into your calculator. $605.00. So what does this look like on a graph? If I was to put this on a graph. Oh. Notice here I only have 2 pages. Oh, no, wait. It's got more. If I put this on a graph, showing your amount in dollars. And this here is going to be N, which is going to be in the number of years. When you first put in your amount of money, you put in $500. After 1 year, your value now increases to 550. After your second year, though, it increases to 605, like so. So you can see the gap. I might move this a bit further up just to show you that the gap is different, yeah? It's very subtle. But the distance between here and here was $50. But the distance between here and here was $55. So going back to this diagram here, you can see it follows the idea of compound interest. Your amount increases every time. Okay. So I'll leave that in the notes there and I'll put that on Compass at the end. Okay. We're going to move on to this section now because this is where we start to really use our equations. Give me a moment. This is going to be recorded. It's going to be on Compass. So the question here asks us determine the amount after 5 years. So what is this saying if we say amounts after 5 years when $4,000 is compounded annually at 8%? There's a lot of information there, but we don't look at this whole sentence at once. We have to break it down. So what do we want to do? The word starts with an A. And we want to annotate. So we want to underline and we want to label, write some notes. What's the first word in this sentence that we're going to underline? 5 years? No. Determine 5 years? Determine what? The amounts, right? So we actually have to figure out what we're looking for first. I want you to take your pen now and underline, determine the amounts. What letter are we going to write here? Yes, the amount stands for A. We have 5 years, which is our time. So let's label that as T for time. When $4,000, that's how much we're putting in, right? So that's our principal amount or our starting value. We'll underline that. That's our P. Any other? 8%. 8%. Are we skipping anything? Compounded annually. Okay, so just make sure that we're looking at compounded. When we talk about compound interest, we have to write the formula for compound interest, yes? So if you scroll back up to the top of your notes or on your first page, you should have this equation here. We'll need to write this down. So maybe turn to your first page and write this down now underneath where that word compounded annually is. So notice here, we're not starting the question yet. We're just gathering information. So we have A equals P times 1 plus R over 100 to the power of N. We've got one more thing. The rates, correct, which is percent. I like to add on just a little bit more. What's it missing? PA. What does PA stand for? Per annum. Per annum is every year. Okay, so this is our R value. Okay, we've got all of our ingredients here. So we've got our formula. Are you noticing that any letters missing? Is any letter missing that from this equation here? We've got our A, we've got our P, we've got our R. Do we have our N value? Do we need our I? Is it asking for the interest? Is it asking for the interest?
No.
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 So we'll just work with whatever we have in front of us. Does that make sense? So here we don't need to worry about our interest at all. Okay, we can figure it out afterwards. But there's another letter that we actually don't have in our equation here. We're missing something. So have a look through again. A, P, that's good, that's good. We've got our R, that's tick. We need to find our N. What does N stand for again? Can you please flick to your first page? Okay. N stands for the number of payments. So how many times does it compound in every year? How many times does it compound every year? It says compounded annually, right? Yearly. So how many times does it compound every year? Just once, yeah? And how many times are we compounding it? How many years are we doing it for? 5. So how many times is it going to compound? Total 5 times. So I'll just write this out. Once a year. For 5 years. I'll just write it out like this so you can actually see why I write N equals 1 times 5. Because in year 11 and year 12, it will say, I want you to compound monthly, or I want you to compound quarterly, or biannually, means every half year. So this number will change, okay? So we want to write this down now as it is, so that I'm preparing you for next year. So this means that N will equal to 5. I'll let you write that down. Now, what was our process that we had to go through? What do we write first to start the answering process? Yes, we start with the formula. Start with a formula. So our formula is A equals P times 1 plus R over 100 to the power of N. So that's our formula. What's our next step? Substitution. Do we know what our A is? No. So we leave it as A. Do we know what our P is? 4,000. So I'm going to replace this with 4,000. I'll actually write it in different colors here. 4,000. We've got our bracket here. We've got 1 plus. What's our R? 8. Notice up here, I've done it in green. So I'm going to write 8 over 100 to the power of 5. Yep, because you can see here, N is 5. N equals 5. So we've got all of our ingredients. Notice this T equals 5 years. That worked into this section here. So this step here was substitution. What's our final step? Answer. So we go to our calculator. We type this in. I want you to give that a go now and see what you get. I'll give you a minute or so. Pull out your calculators in the other classroom. Do it as well. And I'll show you how to type it on the screen as well. Our calculators might be a bit different. That's okay. Okay. If you're using a really basic scientific calculator, I want you to type it in like this, okay? I want you to type these numbers in. 4,000. So I'm just gonna write calculator.